Definitely welcome on to Monday. This is day 33. We're going to be talking about Gay-Lussac and combination gas law today. So let's go ahead and jump on in, and we will definitely talk about the difference between the two of those. Start my timer so I'll know how long we've got. So, Gay-Lussac is pressure of a fixed amount of gas varies directly with the Kelvin temperature when the volume is constant. So we have a P1 over T1 equals P2 over T2. So here we have two different types of, we have the same gas and it has a different temperature. And depending on the temperature, the pressure will go up because the number of collisions that hit the sides. We have pressure and temperature. As you can see, when one goes up, the other one goes up. That's known as a direct relationship. A direct relationship means when one goes up, the other one goes up. An inverse relationship means when one goes up, the other one goes down. Okay? So I want to make sure you know the difference between those. So the first thing we're going to do is we're going to look at the sample problem that they gave us. So on the sample problem for Gay-Lussac's law, it talks about pressure being 5.0 atm. 25 is our temperature. Our temperature 2 is a negative 10, and we're looking for our unknown temperature. So, based on that, remember what we have to do. First things first, we have to change our temperature. We have to add 273 to both of those, right? Plus 273 plus 273, which over here I did, which is 298 Kelvin. And then also it is 263 Kelvin. Make sure you can see everything. And then so the first thing we're going to do is we're going to look and we're going to see what it has to deal with. So let's look and see. So we have pressure 1 over temperature 1, pressure 2 over temperature 2. First thing we're going to do is do our crisscross. Remember, we're going to make it linear. So that's what I did here, is I made it linear. P1 times T2 equals P2 times T1. I looked and see what I'm missing. I'm missing P2. So since I'm trying to get P2 rid of, I need to go ahead and cancel T1 on this side. And so that puts it over here. So then I do 5.0 atm. Get my calculator. So we're going to do alpha y inner, open bracket, 5.00. 263 over 298. When we do that, we get 4.41. And then the next thing we need to do is we need to check our answer. So this right here is our pressure 2, right? 4.41 atm. So what we're going to do is we're going to put it back in our original equation. So we're going to do alpha y, and then we're going to divide that by our temperature 2, which is 263. And we get 0.016778523 Okay, that's my check answer. So then I'm going to do the other side, which is my P1. So I'm going to do 5.00, and I'm going to divide that by my T1, which is 298. And I get the same answer. So there's my check answer. Here is my answer for it, 4.41. And then let's go on to the next problem, which is number 8. It says the pressure of an automobile tire is 1.88 atm at 25 degrees Celsius. What would be the pressure if the temperature increased 37 degrees Celsius? So the first thing I did is I changed my temperatures, adding 273 to both of those. Then I wrote out my formula again, where I crisscrossed it. I looked and saw what I'm looking for. I divide those, and I got my answer at 1.955704998. And my check answer is this. So based on that, I'm going to say that what I was looking for, which was P2, is 196 atm. Okay? So now let's go on to number 9. Number 9 says a helium gas at 2.0 liter, okay, if is under 1.1 atm at 36.5 degrees Celsius, the same. So that's my temperature 2. I started with temperature 1. I was wrong, right? same gas pressure at 2.56 atm. What is the initial temperature in Celsius? Is the tank. So I'm doing my P1 times T2 equals P2 times T1. I'm trying to find temperature 1, so I need to divide both sides by P2. And once I do that, I get 135 degrees Kelvin. So then the next thing I'm going to do is I'm going to go ahead and put my number in, 135 degree Kelvin. So it says if I take my pressure 1, so let's clear this and let's go alpha Y, enter. And I need to take my pressure 1, which is 1.12, and I need to divide that by my temperature 1, which is 135 degrees Kelvin. I get 0.0082962963. And now I'm going to check my answer with my other one. So then now what I'm going to do is I'm going to do my pressure 2, which is alpha Y, enter, 1.12, and I'm going to divide that by my temperature 1, which, pressure 1 by my temperature 1. Okay, and they both equal. So we're all good. There's my check answer, and there is my answer for that one. Now, if you notice, I did put volume 1 in here, but the volume didn't change, so I didn't need to have that, but it was kind of using that to help you with the combination gas law. So then the next thing we want to talk about is the combination gas law. Now, the combination gas law states that the relationship between pressure and temperature and volume of a fixed amount of gas. So we have P1 times V1 over T1 equals P2 times V2 over T2. So first thing we're going to do is going to do the crisscross method. To do the crisscross method, we're taking the fraction and making it into a linear one. After that, we're going to check our temperature to make sure that it's Kelvin, because it's supposed to be in Kelvin. Most of the time we want to make sure that our volume is in liters, but sometimes if it specifies they want to keep us in milliliters, sometimes we do, so it's depending on that. So let's look at the practice problem that they have. So we have pressure 1 at 110 kilopascal, 30 degrees Celsius, which we changed to 303, 2.0 liters, which we kept. Our pressure 2 is 440 kilopascal. Our second temperature is 80 plus 273, which is 353. And we're looking for volume 2. So this one's a little different. So we first of all start off with changing it to linear. Okay? So I'm taking P1V1 times T2. And then P2V2 times T1. So I'm just crisscrossing like I've done before. But this time, instead of one variable, I'm going to take two variables off. So since this one, I'm looking for V2, I'm wanting to take P2 off and T1 off to get it by itself. So that means I have to do the same thing on this side. So then what I do is I just go and take my numbers, do my multiplication, and I get 0.582050082548. I take that number, plug it back into the original formula, and my check answer is 0.72607260032. Is going to be my check answer, so then I know my problem is right. So let's look at problem number 11. 11 says a sample of air as a syringe exerts a pressure at 1.02 atm at 22 degrees Celsius, which we added to make Kelvin. Okay, the syringe placed in boiling water bath at 100 degrees, so I'm going to change that to 373 degrees Kelvin. The pressure is increased to 1.3 atm and by pushing the plunger, and reduces the volume at 0.0224 milliliters. What is the initial volume? So I'm going to go ahead and just keep this one in milliliters, and then after that I'm going to do it also in doing the equation here to changing it to liters, because that's what I was doing there. So first things first, crisscross, get what you don't want off, plug everything in, and you should get 2.13 times 10 to the negative 1 is your answer. Question number 12. A balloon contains 146 milliliters. okay, of gas confirmed with a pressure of 1.30 atm and the temperature is at 5.0 degrees Celsius. Convert that to Kelvin. If the pressure doubles, so what I did is I took 130 and multiplied it by 2, which I get 2.6 atm because it doubles. And the temperature decreases at 2.0 degrees Celsius, which means it goes down to 275 degrees Celsius. And what is the volume of the balloon? So we're looking for volume 2. Same thing again. Crisscross, divide from what you want to know. Put your number in and you get 72 milliliters, and that is your answer. So then the last part is the most important part that you probably will have in your ISM book, is your formulas for these 4 gas laws that we've done so far. So we have Boyle's, Charles, Gay-Lussac, and combination. So at the very bottom, we actually have this one, which is going to show you which way they're going. Okay, so this is going to tell you that you're doing pressure and volume here, you're doing temperature and volume here, you're doing pressure and temperature here, and how the combination law all combines it all together. Okay, so please refer back to this video to help you, because tomorrow you'll have some practice problems to do, which I'll go over, and I'll try to make it an earlier time tomorrow for you so that you can actually see it. Please refer this as your practice. Remember, you only have until Friday, and then you'll need to use the rest of the time for makeup work. I hope you have a blessed day.